Every single photo NASA has ever shown you is incomplete. Hubble, James Webb. They are the sharpest eyes humanity has ever built, but together they've only captured a measly 5% of what's actually out there. The rest? No light, no color, no shadow on any camera in history. We are structurally blind to our own universe, which raises a terrifying question. How exactly do you photograph something that gives off absolutely zero light? The answer is about to break everything you thought a camera could do. With the launch of NASA's next-generation flagship, the Nancy Grace Roman Space Telescope, the era of blind spots is over. A mission built specifically to solve this cosmic mystery. It carries a camera 100 times larger than Hubble's. It wasn't just built to take prettier pictures. It was engineered for one specific, impossible mission: to track down dark matter, the invisible ghost that controls 85% of our universe. But to hunt a phantom, you need more than just the sharpest eyes in history. You need a perspective so massive, our current space telescopes physically cannot achieve it. Not even Hubble, orbiting 340 miles above your head. And not even James Webb, parked a million miles away, staring back to the dawn of time. Because as miraculous as these two machines are, they're structurally blind to the bigger picture. Picture yourself inside a packed stadium, roaring crowd, lights blazing in every direction. Now imagine watching the entire game through a drinking straw. That's Hubble, that's Webb. Sharp, detailed, stunning, but painfully narrow. Point it at one galaxy and every detail explodes into view. Shift an inch to the left and you have no idea what's there. To map the whole sky this way, Webb would need centuries. And we don't have that kind of time, because dark matter doesn't hide in one tiny patch of sky. It stretches across billions of light years. But that's not the only mystery. Dark energy is doing something even stranger. Imagine a loaf of bread with raisins in it. As the bread bakes, the space between the raisins expands in every direction, pushing them apart, while the raisins themselves stay exactly the same size. That's our universe. An unknown force, dark energy, is stretching reality itself, and we have no idea why. You can't map an entire sky through a keyhole. Nobody had built a telescope wide enough to see it. Until now. Picture an eye with Hubble's exact same sharpness. Now swap the straw for the widest lens ever built for space. That's Roman. Its mirror, 2.4 meters wide, the same size as Hubble's. But here's a secret NASA rarely talks about. This multi-million-dollar mirror didn't start as a science instrument. It began as classified military hardware, built for a spy satellite that never even launched. Then the National Reconnaissance Office had no use for it anymore. So in 2012, they handed it to NASA for free. That's the mirror sitting at the heart of Roman today. Bolted behind it, a camera unlike anything before, over 300 megapixels, capturing a field of view 100 times larger than Hubble's. To grasp how massive that actually is, displaying just one single Roman image at full resolution would take over 500,000 4K TVs, enough screens to cover the entire face of El Capitan in Yosemite National Park. One click of the shutter, and Roman captures what would take Hubble 100 separate photos to stitch together. That kind of shot has a name, a cosmic panorama. And it carries the legacy of Nancy Grace Roman, NASA's first chief astronomer, known as the mother of Hubble for fighting through a wall of skepticism to push that telescope into existence. She passed away in 2018, but today her dream is officially leaving Earth behind. Follow it as it drifts out, nearly 1 million miles from home. Arriving at a quiet, frozen point in space called L2. Cold, dark, undisturbed. Solar panels unfold like wings catching sunlight for the first time. The mirror opens, an eye waking up after a decade asleep in a clean room. Then it begins. Roman starts photographing the sky. Not one galaxy, not 100, billions. Frame after frame, patch after patch, year after year, the cosmic panorama grows. Suddenly, we're not looking at single snapshots anymore. We're looking at a moving map of the entire universe evolving in front of us. But why would we need billions of galaxies in a single photograph? Because this cosmic panorama isn't just for prettier pictures. It's the only way to catch dark matter, the invisible force that has stayed hidden since the birth of astronomy. Something that outweighs every star and galaxy combined and still leaves zero trace on any camera. That's a job no single telescope can do alone. But Roman isn't here to replace Webb. This isn't a competition. It's a cosmic partnership. Think of James Webb as a hyper-focused zoom lens staring deep into one tiny fraction of the sky. Roman is the ultra-wide-angle lens. It scans the vastness of the cosmos to find the anomalies and then tells Webb exactly where to zoom in. This is the ghost from the very beginning. Dark matter. Nobody has ever seen it directly. Not once. Not with any telescope ever built. It doesn't glow. It doesn't reflect light. It doesn't block anything in its path. To your eyes and to every camera in history, it's completely invisible. But it hasn't disappeared. It's everywhere. Wrapped around galaxies like an invisible skeleton holding them together. And this brings you back to the impossible riddle from the very beginning. How do you actually photograph something that gives off zero light? The answer: you stop looking for the ghost, you look for its shadow. Because dark matter has mass, and mass bends space itself. Einstein figured this out over a century ago. Picture a bowling ball dropped onto a stretched out bedsheet. The fabric dips, it curves, it warps. Anything rolling nearby suddenly changes direction. Now scale that up. A massive, invisible clump of dark matter sits between you and a distant galaxy. Light from that galaxy has been traveling toward you for billions of years. Right as it passes through that warped patch of space, it bends. Picture dropping a marble into a pool of water, staring at a coin resting on the bottom. The coin isn't where it looks like it is. The water bent the light on its way to your eyes. Now replace the marble with an invisible cloud of dark matter the size of an entire galaxy cluster. Replace the coin with the light from a galaxy sitting behind it. Suddenly, that background galaxy stretches, smears, warps into a faint glowing arc across the sky. Astronomers call this gravitational lensing. Dark matter photobombing every photo of deep space, leaving fingerprints of bent light behind something you will never see directly. But that's only the beginning. Dark matter isn't hiding in one lonely cluster. It spreads across the entire universe. Filaments, knots, a cosmic web connecting galaxy to galaxy, invisible thread by invisible thread. So what happens when we photograph billions of these bent, warped galaxies at once? That's Roman's real mission: photograph billions of galaxies, measure every warp, every stretch, every smear of light. Then, piece by piece, on a screen somewhere at NASA, a shape starts to form. Luminous cosmic highways, massive gravitational hubs, the entire hidden scaffolding of reality rendered visible for the first time in human history. When NASA pieces this together, we won't just be looking at a map. We'll be looking at the cosmic web, the literal framework holding us and every galaxy around us together. We are finally looking at the ghost in the room. For decades, humanity explored space through a straw. Narrow, deep, breathtaking, but painfully limited. Then Roman arrived. It stepped back. It thought bigger. It opened its eye wide. As the Falcon Heavy rocket roars into deep space, we officially stop looking through a straw. The invisible universe is finally becoming visible, and we are here to see it happen.